Assalamualaikum, selamat sejahtera. We go to the next question, exercise 2 under 7.2 acid-base titration. Okay, if you get like this question, what the first step that you must do? Okay, based on this question, in experiment at 25 degrees, total mil 30 mil 0.2 molar NaOH is added dropwise into conical flask containing 25 mil 0.2 molar acetic acid. Alright, calculate the pH of the solution before addition, at half equivalent, at equivalent, and after addition 30 mil, then sketch the titration curve. As usual, you have to sketch roughly the titration apparatus. Why you have to sketch? Because you want to know the type of acid-base titration, either type 1, type 2, or type 3. Okay? NaOH is added dropwise, that means your titrant is NaOH. Conical flask containing, that means your analyte is ethanoic acid. After you determine which one titrant and analyte, you have to classify. This is strong base, this is weak acid. So since it involves strong base and weak acid, so it under type 3, which is strong base weak acid titration. Okay. Based on the data, volume, total volume. What means by total volume? The final reading of the titrant is 30 mil. So, I don't know before 30 mil how many mil is added to the analyte. So, we don't know the volume of NaOH secara exactly, but the molarity, yes, exactly I know is 0.2. How about analyte? Your analyte molarity is 0.2 and the volume is 25 mil. Okay, the question asks you calculate the pH of the solution. As usual, pH of the solution is referred to the pH analyte. That means in the conical flask all the time. Okay, so we go to the first part, part A. Calculate pH analyte before addition NaOH. That means before you added titrant to add an analyte, you have to calculate the pH in this conical flask. Okay, you analyze in the conical flask, you only have weak acid. So, how you want to find the pH of weak acid? Yes, you have to use ice table because this is weak acid. Based on ice table, you can find the pH of weak acid. So, if you want to starting with ice table, you have to dissociate your weak acid. CH3, COOH, right? Aqueous, a reversible arrow becomes CH3, COO minus, because this is weak acid. That means this is a proton donor. Okay, and H plus. Next, inertial change equilibrium. The unit for ice table here is molarity. Okay, initial concentration for ethanol acid given here 0.2. Not yet produced. Okay, change. This is unstable. That means you have to put unknown here. Reactant negative, product positive. So the final equilibrium 0.2 minus X, X and X here. This is your I stable. After you get I stable, you have to draw the Ka expression. Okay, CH3 COO minus H plus over concentration CH3 COOH. Then you have to substitute the value. Okay, as we know, Ka did not given in the question, right? So please make correction. Ka for acetic acid should be given in the question. Alright, 1.8 exponent negative 5. Okay, then you substitute the value here. 1.8 exponent negative 5. Insert the value from the equilibrium row here. X 0.2 minus X. As usual, you have to checking 5%. Checking 5%. Why you have to check? Because the Ka value is given. Ka over initial square root times 100. 1.8 exponent negative 5 over 0.2 100, and you get here 0.94%. This percent is less than 5%. So what you should do, yes, Ka very small than 1. So assume bahagian denominator ini assume 0.2 minus X approximate X. Di sini kita assume X ini can be negligible. Okay, very small. That's why 0.2 tolak nilai yang kecil, dapat balik, kita akan dapat balik nilai dia, iaitu 0.2. Okay, after you assume, you rewrite again the expression X squared over 0.2, and you get the value of X, which is 1.8974 exponent negative 3. So that concentration X. Okay, X equals concentration H plus equals to 1.8974 exponent negative 3. So based on this, you can get the pH, negative log 1.8974 exponent negative 3 become 2.72. So this is the pH before you added titrant to the analyte. So you have to refer in the conical flask what the solution remain in this conical flask. I use ice table because the solution in the conical flask only have weak acid. That's why I use ice table. Now we go to the next question. Calculate the pH of the solution B at half of the equivalent point. Based on the previous lesson, video, I will show you the first step. If you want to find the pH at half equivalent point, the first step, you must find for me the volume titration added. Okay, at half equivalent point. Betul? Okay, macam mana kita nak cari volume titration? Okay, kita tahu at equivalent point, okay, mole acid akan sama dengan mole base. Alright, so nak dapatkan mole kena guna formula M, okay, over MB VB, okay, A over B. So this, you nak dapatkan Stokio, you kenalah buat equation dahulu. Equation antara apa? Strong base and weak acid. What the product form? Macam biasa, silangkan charge, you akan dapat sodium ethanoate and H2O. Based on this, Stokionya 1 here, Stokionya 1 untuk acid. Thus, di sini kita boleh calculate molarity acid is 0.2, volume acid adalah 25 ml, over molarity base adalah 0.2, volume base kita nak cari 1/1, so volume base di sini adalah 25 ml. Kenapa saya guna this formula? Sebab dia berlakunya neutralization. When you added titrant to the analyte, di situ dah bermulanya neutralization. Bila berlakunya neutralization, yes, you can use this formula. Okay, kita nak cari, bila guna this formula, kita nak tengok berapa volume yang telah dimasukkan ke dalam analyte untuk melakukan neutralization. That's why I use this formula untuk dapatkan volume titrant yang dimasukkan. Okay, volume base ni lah. Alright, tetapi ini pada at equivalent point. Saya tak nak pada at equivalent point. Saya nak pada half equivalent point. That means volume base kena bahagi dengan 2. 25 bahagi 2 dapat 12.5 mil. Bermaksud pada half equivalent point, hanya 12.5 mil sahaja titrant yang dimasukkan ke dalam analyte untuk melakukan neutralization. Okay, untuk reach half equivalent point. Step number 2, you kena cari mole. Mole siapa? Mole HCl dan mole NaOH. Okay, right, sorry, di sini bukan HCl your acetic acid. Okay, same goes untuk yang ni adalah mole acetic acid. Okay, guna formula MV over 1000, molarity, volume, and you punya 1000 akan dapat 5 eksponen negatif 3. How about mole base here? MV over 1000. Okay. Okay, volume di sini adalah volume at half equivalent. Berapa? Yang ini kita cari. Okay, 12.5 over 1000 become 2.5 exponent negative 3. This is mole in conical flask. This is a mole of titrant. Okay, this is a mole from burette that added to the conical flask to reach half equivalent. Alright? Okay. Next, after you get the mole, you have to use ICF table. ICF table diguna pakai untuk acid base titration. Okay, kenapa diguna pakai? That means bila titrant dah dimasukkan ke dalam analyte, di sini perlunya kita menggunakan ICF table. What the unit involved in ICF table? Yes, mole. Only mole. As usual, ICF table we're starting with the equation. Equation dissociation? No. Equation reaction neutralization. That means your strong base here react with your weak acid here to produce the salt and water as usual. Okay, balancekan. All the phase is aqueous, include your salt, except your H2O in liquid. Okay, next, initial, change, and final. All the row in unit mole. Okay, mole NOH CH3 COH refer pada step number 2 here. You masukkan mole NOH adalah 2.5 eksponen negatif 3 yang ini, dan mole CH3 COH adalah 5 eksponen negatif 3. Ini kosong, belum dihasilkan, involved in your ICF table. Di sini bila kita guna ICF, ingat pada row change kita tak guna unknown X, kita guna nilai limiting reactant. Between these two reactant, nilai siapa yang paling kecil, itulah limiting reactant kita. So di sini 2.5. So semuanya terlibat dengan 2.5. Right, di sini pun 2.5 eksponen negatif 3. Yang membezakan di sini reduce dia punya concentration reactant reduce dia punya concentration, but product increase dia punya concentration reactant. The sign compulsory include. The final mole, okay, adalah I tolak C. That means 2.5 tolak 2.5 will become 0. 5 tolak 2.5, 2.5 eksponen negatif 3. Ini akan jadi negatif 3. Okay, di sini siapa yang limiting reactant? Macam tadi kita tentukan NOH adalah limiting reactant sebab nilainya lebih kecil daripada 5 eksponen 3. So limiting reactant itu at the end, pada final, dia akan menjadi 0 sebab dia completely consume. Okay, itu differential untuk limiting reactant. So tally lah with the value here. Macam biasa, after you get the ICF, tambah lagi satu row di bawah, dinamakan molarity M, mole per volume total. Volume total here refer to the volume CH3COOH plus volume NaOH at half equivalent. Okay, so di sini kosong, artinya kosong lah. So di 2.5 eksponen negatif 3 bahagi dengan volume total. Berapa volume CH3COH dalam conical flask? 25. Berapa volume NOH yang kamu added pada half equivalent? Yes, 12.50. Tukar menjadi liter. And you get the volume here is 0.0667. How about this? 2.5 exponent negative 3 over volume acetic acid plus volume at half equivalent, convert into liter, and you get 0.0667. Okay. After you cari molarity, bermaksud yang berbaki di dalam conical flask selepas reaction neutralization adalah molariti untuk ethanol acid dan molariti untuk CH3CONA. Ini molariti salt, ini molariti weak acid. Inilah molariti yang berbaki di dalam conical flask selepas neutralization reaction. Okay? So based on this, kalau kita tengok berbakinya ada dua benda, iaitu weak acid dan salt. Ini adalah campuran antara weak dan salt, menjadikan campuran ini mewujudkan buffer solution. Am I right? Yes. Kalau you ada campuran salt dengan strong, dia tak jadi buffer. Okay? Dia akan strong, itu akan dominan di dalam your conical flask. But ini sekarang campuran salt dengan weak, that means dia tak dominan, tetapi dia mewujudkan satu solution yang baru yang dinamakan buffer solution. Okay? So, macam mana kita nak cari pH buffer? Okay. Masih ingat nak cari pH buffer? pH buffer mesti menggunakan Henderson-Hasselbalch equation. Kalau pH untuk acidic, kalau dia pOH untuk basic. Okay? Now, I want to ask you, this campuran adalah acidic buffer or basic buffer? The answer is acidic buffer, because it involves weak acid here. So kalau ini adalah acidic buffer, that means you have to use Henderson-Hasselbalch equation for pH. So now pH equals to pKa plus log concentration salt over concentration weak acid. Okay, pH that I took before, kita tak terima dalam keadaan macam ni. Kita nak yang spesifik. pKa plus log CH3COONA over weak acid CH3COOH. Okay, then you substitute the value. pH equals to P negative log Ka 1.8 eksponen negatif 5 plus log concentration salt, yang inilah kita ambil dari concentration salt 0.0667 over ini concentration weak acid 0.0667. You settle down using calculator and you get the pH is 4.74. This is the pH after you added at half equivalent point. That means this pH refer to the remaining solution in the conical flask.